Greetings to every one of you. In this video, we are going to discuss hierarchical clustering algorithm. It is another unsupervised machine learning algorithm. This used to group unlabeled data sets into a cluster. This algorithm overcame the problems of k-means algorithm, in which we got two problems. One is we need to predefine the number of clusters, and also it used to create the clusters of same size. This hierarchical clustering algorithm, it has two different methods. So one is agglomerative hierarchical clustering and number two is divisive. So this agglomerative hierarchical clustering, which is a bottom up method, and this divisive, it is a top down approach. Let us see the various steps of this algorithm. First of all, we have to compute the proximity matrix with the help of the Euclidean distance formula. So the distance between the data points, it has to be that is calculated by means of its nearness, closeness. Step number 2, form each data point as a single cluster. If you have n number of points, then the number of clusters is equal to n. Consider two closest data points or clusters and merge them to form a cluster in which the number of the clusters will become n minus 1. Once again, we have to consider the closest clusters, merge them together to form the next cluster. The number of clusters now has become n minus 2. So repeat this step 4 till we will get one cluster left out. After finishing this, once all the clusters are combined, so we will get a big cluster, and using that we can finally draw the dendrogram. Let us see how to do this with the help of this example. For example, these are the data points or the clusters that is given. We consider all these data points as the clusters. So each one is a single cluster. Now we have to combine the clusters based on the nearness, the proximity, the distance. So let us consider here AB. These are the two data points which are that is close to each other. So we can make the cluster with the help of 2 points, that is AB. Similarly, this PQ, it is another close data values. So we can make another cluster here, that is PQ. Then the next scan, you can find this D, maybe that is close to, that is this cluster AB. So combine these two, make this cluster, that is A, B, comma this D. Similarly, you can combine this cluster, that is S, with cluster PQ. This is PQ, comma S. So combining these two clusters, we can make the final clusters, that is this is AB, comma this is D, then this is PQ, comma S, and finally you can combine. So you'll get all these data points combined together into a single cluster. So let us consider, here we have this data points here. So initially we make the cluster using the two data points, that is A and B. Then we combine this D. Similarly, PQ as single cluster, and we combine this S with this, and finally we have the overall cluster. So the same thing, once if you finish this work, so this is what is called from the bottom to the top, we clustered, we grouped the data points. So this is what is called agglomerative. The method is what is called the agglomerative. So here we have done from bottom to top. The reverse process, so let us consider this is the given overall the cluster, and it is divided into, this is A, B, D, P, Q, S. It is divided into two parts, that is A, B, D, P, Q, S. And then this A, B, D, it is divided into A, B and D. A, B is divided into, finally that is A and B. Similarly, P, Q, S, it is divided into P, Q and S. P, Q is divided into, that is P and S. So this is the method. So what is called, this is divisive. It is top down. It is top down approach. This is bottom up approach. This is bottom up approach. So agglomerative means it is from the single data points, just move to making the single cluster, overall cluster. And this divisive is from the overall cluster divided and splitting into its individual data points. Now how to draw this dendrogram? Dendrogram can be, that is drawn by combining. So here actually this A and B can be framed, that is combined together into a single cluster, and this D is another single cluster. This can be, that is combined like this. Similarly, PQ can be combined initially, and then this S can be, that is combined with here. So here it is PQ, this is S. So this here it is PQS, and this is AB and this is D. So this is ABD. Now the overall we have to combine. So it is ABD and PQS. So the way you can represent the clustering in the form of a tree structure, it is what is called dendrogram. So this is the one level. So next level, last level. This dendrogram can also be drawn like this. For example, the same data ABD, PQ, yes, are here. It is combined. So here we have, this is AB, and combine this single cluster, that is D, with the cluster, that is AB. So here you will get AB, this is D, and similarly this is PQ, and this can be, that is combined with the single cluster, that is PQ, yes, and finally we can combine these two together, and this is ABD This is PQS. This is also another way of representing this dendrogram. There are different applications of this hierarchical clustering. So, the hierarchical clustering can be used in document analysis, fake news detection, detecting the crime. I hope you understood the concept. I explained what is hierarchical clustering, how this hierarchical clustering it is advantageous over the k-means clustering, and explain this algorithms, its steps, and also I explain the algorithm with the help of this example. Thank you. Keep watching.